Question for the rotated hyperbola described by x squared minus 3xy plus y squared equals 1. Part A, they want you to show that that is actually the derivative. We did something similar to this on Thursday. That was the day. One reminder is they will never, they being the College Board, will never, ever, ever give you a graph. Because you're going to be tempted to answer the question based on the graph. I want you to do all the work based on the knowledge that you have of calculus. I expect that most of you guys can finish this one completely on your own if you were here on Thursday. People that weren't here on Thursday, where are you? Why don't I get, Daisy, can you join over here? Martyr, why don't you come on up front and let's just work through this one start to finish. But the folks that were here on Thursday, you're doing this one on your own. All right. I had a rag. I hit my rag. All right. Ooh-wee. All right. All right. We've got x squared minus 3xy plus y squared equals 1. So Daisy, you were absent. Edgar was absent, and Martyr, you guys were absent, right? But we watched the video. I'm just going to assume that you have. So on Thursday, in that video that I posted for you guys to watch, that you watched, we talked about the fact that these are called implicitly defined curves. What is immediately noticeable as being different when you first look at this?
The variables are on the same side.
We've got the variables mixed together on the same side. That makes it an implicitly defined curve. I'm going to keep using the word curve. I'm not ever going to use the word function because
since the variables are together, there's not like an actual function, like y is in a function.
okay, normally when you guys think about functions, you're probably thinking like y equals stuff, right? F of x equals stuff. This is not in that form, and I'm not even interested in getting it to that form. But there's another reason why I will use the word curve, but I will never use the word function. Functions are special to us. Functions are very, very special to us.
Is it because, it's kind of similar to what he said, but is it because it's x and y, like in one?
It is possible that that's the problem, but if you look at the graph, there's another reason why I'm going to call this a curve, not a function. Look at the graph. Why would you not use the word function with this graph? Marvin.
Is that a function has one y value for x value?
For every x value, there is no more than one y value. There's this thing that we call the vertical line test. And so I'm not going to use the word function over here. This is not a function. This is going to be a curve. So we're still going to find the derivative. That's okay. We're going to use derivative rules, but things are going to be a little bit different for us. Easy step here. Derivative of x squared? 2x. Nothing new there. Minus 3 times, now I need to take the derivative of xy. And this guy over here is going to be a product rule. What I'm going to do just for this first step, I'm just going to write this as derivative of xy. I haven't actually taken a derivative yet, but I'm using that good calculus notation to say, hey, I'm going to come back to this in a little bit. Now I need to take the derivative of y squared. And the derivative of y squared is going to be 2y times dy dx. And the reason for multiplying by that dy dx is that y is a function of x. Y depends on x. It's a chain rule kind of thing. If I said, hey, I've got all of this stuff squared, the power rule says bring the power down in front, reduce the power by 1, and multiply by the derivative of the baby. The derivative of y is dy dx. And over here, the derivative of 1 is going to be 0. I'm not done with the calculus yet, but I'm getting there. Edgar, how do you know I'm not done with the calculus yet?
Because we still haven't held a definite number for the derivative.
I actually haven't found a derivative yet over here for this product x times y. But good news, I think we know how to do that. That's just your product rule. So product rule says take the derivative of the first, which is 1, times, leave the next guy alone, plus x times the derivative of the second guy, dy dx, plus 2y dy dx is equal to 0. For folks that were here on Thursday, how's the derivative looking? Kimberly's good, Jasmine are okay, Jennifer, are you okay over there? Okay. So the goal here is to solve for dy dx. And the one that we saw a little bit ago just had dy dx showing up in one place. Now I've got dy dx showing up in both places, or in more than one place. The key to figuring out dy dx is to do a little bit of distributing. And then what we're going to do is we're going to collect terms that have dy dx on one side of the equation, and terms that don't have dy dx, move them to the other. So let's clean this up. I've got 2x, distribute that negative 3 minus 3y, minus 3x dy dx, plus 2y dy dx is equal to 0. Not doing any calculus anymore, it's just algebra. I've got a dy dx over here. I've got a dy dx over here. What we said is we're going to take any term that has this dy dx in it and keep it on one side. All the terms that don't have dy dx, move them to the other. Legal? Absolutely. So, Edgar, what's the legal algebra you're going to do here?
Can we subtract 2x?
Right now? I'll send them in a bit. Thank you. Okay. So the legal algebra, I'm going to move the 2x and the negative 3y over to the other side. So we've got negative 3x dy dx plus 2y dy dx is going to be equal to negative 2x plus 3y. And that's good, but that's not quite what we're being asked to show in part A. What I want in part A is I want to know what dy dx is equal to. So David, what's the good algebra that you want to share with your friends up front here? I've got a dy dx showing up over here. I've got a dy dx showing up over here. The good algebra. This is not calculus anymore. What's the algebra that I need to get dy dx by itself? Okay, if not David, how about somebody else? I've got dy dx. You guys must have done lots of these this weekend in the homework. I want to get dy dx by itself. Jasmine, what are you going to do?
Can you divide?
I've got a dy dx over here in this term and a dy dx over here in this term. The legal algebra. Jennifer, what's the legal algebra?
I don't know if this is right, but do you divide by negative 3x plus 2y?
Before I would divide by this negative 3x plus 2y, I want to bring you guys back to the fact that we kept the terms that have a dy dx together on the same side. Not so that we can combine them, but so that I can factor this out. The dy dx is a common factor. So we've got dy dx times negative 3x plus 2y equals negative 2x plus 3y. Now is when I'm going to do the dividing. So dy dx is equal to negative 2x plus 3y over negative 3x plus 2y. For the folks that were just doing this on their own, how many guys came up with this as your derivative? 1, 2, 3, 4. Okay, so Martyr and Daisy, I guess you guys are needed in the front office. Hopefully it's going to be really, really quick, and if you can impress upon whoever's there waiting for you that it needs to be really, really quick, that'd be great. Talked about how much time you guys have missed. All right, so now that they're gone, let's move on to parts B and C and maybe even part D. This is where I've got everybody now. I got all the brains. So, if you successfully made it to part A, great, fabulous, life is good. But what if you didn't? Could you still do part B?
Yeah.
Maybe. Maybe. Look at part B. Determine the equations of the tangent lines at the X intercepts. I want equations of tangent lines at the X intercepts. What do we know about X intercepts, Jose?
Crosses the x-axis.
Okay, an x-intercept, so if we're in part B here, an x-intercept means crosses x-axis. Now, you might be tempted to look at that graph and say, I know where the x-intercepts are. Don't do it because they're not going to give you the graph to look at, so you can't do that. So how do we find x-intercepts? If you're crossing the x-axis, what do you know? One person. You're crossing the x-axis. Think about all those points. Noemi, what do you know?
We're looking for horizontal tangent line.
We're not looking for horizontal tangent lines. This isn't a calculus thought that you need right now. It is an algebra thought. X-intercept. Abraham, what do you know?
So y has to be equal to 0 so that it crosses the x-axis.
Right. All x-intercepts always have the form something comma 0. What you know is that the y value is equal to 0. Noemi, you okay with that? Okay. So let y equal 0. If y is equal to 0, I'm going back to the original, and I'm saying that means x squared minus 3x times 0 plus 0 squared is equal to 1. So I think we get x squared is equal to 1. If x squared is equal to 1, your solutions are going to be plus and minus 1. My x-intercepts are 1 comma 0 and negative 1 comma 0. And if they gave you the graph and you looked at the graph, do those feel right? Right? I can see on the graph, and this is why they're not going to give you the graph. It kind of cheapens the whole experience. Not done. Why are we not done? Why are we not done? Jonathan, why are we not done here? What is it that we're looking for in part B, John? The equation of, okay, have a quick strategy conversation with somebody near you. What are you going to do? So we've got the x-intercepts, the piece that you're missing, the critical piece that you're missing.
Oh,
You need the slope. Christian, where's that slope going to come from?
You plug these into the derivative.
The secant line.
wait, where did it come from, part A?
They're asking for the equations of the tangent lines. We've got an x-intercept at 1 comma 0 and an x-intercept at negative 1 comma 0. The piece that you're missing is you don't have the slope. How are we going to get the slope? Still on Christian here. How are we going to get the slope of the tangent line?
Would you plug in 0 for x and then to try to find the...
Okay, we need some help here. Giselle.
You plug in those points into the derivative.
You're going to plug these points. Because you need the slope of the tangent line, you're going to go back to the derivative. And you're going to get the slope of the tangent line using the derivative. Okay? So dy dx at 1 comma 0. So x is equal to 1, y is equal to 0, negative 2 times 1 plus 3 times 0 over 2 times 0 minus 3 times 1. So 2/3.
I got negative 2/3.
Negative 2 plus 0 over 0 minus 3. So I've got negative 2 over negative 3.
Oh.
So 2/3. Great. Equation of the tangent line, L of x equals 2/3 parentheses x minus 1 plus 0. If I go for the other one, dy dx at negative 1 comma 0 is going to be negative 2 times negative 1 plus 3 times 0, 2 times 0, minus 3 times negative 1. I think we're getting positive 2 over positive 3. So L of x equals 2/3 x plus 1 plus 0.
Do we have to say like add for each tangent line do we have to say at what point? Like in a kind of.
It would be a really good idea so that you make sure you're getting all the stuff correctly. Oh, thank goodness you're back. Right, I'm going to find the derivative at 1 comma 0. I'm going to find the derivative at negative 1 comma 0. Now, one big mistake I need you guys to avoid is what I just wrote on the board. I deliberately made a mistake here. Something that is costly. I wonder if anybody sees it. David, what do you see that you don't like?
Is it that you wrote or that you didn't?
My math is good. My notation is bad. My notation is bad. We've never run into this problem before, at least not that I can think of. Jasmine, what do you see?
Did we not write an explanation?
They're not asking for an explanation. That's not the problem. Abraham, what do you see?
Is it that you just left L of X and you didn't write L1 and then L negative 1?
Right. The problem is L of X is equal to this guy over here, and at the same time I'm saying L of X is equal to this guy over here. I'm talking about how many lines? Two different lines. If I'm going to do 2 different lines, I need 2 different equations. So let's call it like L sub 1 maybe, and call it L sub 2, or maybe you want to call it M of X and N of X, whatever you want, but don't double down and use the same variable twice. All right, part C. Part C. Here's what I want you guys to do. Show me what you can do on part C. I know in part C it says evaluate d squared y dx squared at the x-intercepts. I am not interested in your doing both. We don't have the time for both. What I want is at the x-intercept, the one that I want you guys to focus on is at the point 1 comma 0. Let me take attendance, check in with a couple of folks. Back them out. 4, 6, 9,
Why is the d squared and then the x?
This is original. Right. They're using like expanded. So that's what they tell us. Like you're learning
I hope everybody is in the process of using the quotient rule. Right, I'm going to take the derivative of the derivative. So I'm going to have low d high negative 2 plus 3 times dy dx, low d high minus high d low all over low, low. How many guys honestly have that as your derivative? You've got the dy dx is showing up in the right places. Okay, Jasmine, what's your next move?
Well, you said it, you said the, not the function. Except the second derivative.
Okay, but why are you setting it equal to 0?
Or no,
The question's asking for the second derivative at the x-intercept, so what are you going to do? The number line test, you're not going to do the number line test. They're asking for the value of the second derivative at that point. Jasmine, what are we going to do?
You put in the points.
Right, everywhere there's an x, you're going to put in 1. Everywhere there's a y, you're not going to set it equal to 0. We're not looking where the denominator is equal to 0.
Evaluate.
You're just evaluating. You're just plugging in. Some of it's going to be wicked easy. 2 times the y value. 0 minus 3 times the x value. How about negative 3? Parentheses, negative 2 plus 3 times the derivative. And this is the one that's going to sneak up on you.
Don't you have to use this equation?
Right, I'm asking for the second derivative at 1 comma 0. Good news. You already know what the first derivative is at 1 comma 0. We found that in part B. So it's negative 2 plus 3 times, what was it? 2 thirds. Minus, over here, negative 2 times x, that's negative 2, plus 3 times 0, negative 2. 2 times dy dx again, minus 3, all over 2 times the y value, minus 3 times the x value squared. Evaluate the second derivative at the x-intercept. Have we evaluated?
Yes.
Have we simplified? No, but we've evaluated. And so like their first part is, we're done. But now they want me to talk about the concavity at this point. So to get the concavity at this point, it's not even the second derivative test. I just need to know the sign, positive or negative. So you are going to have to simplify a little bit, but let's be clever. Let's see. 3 times 2 thirds? 2. Negative 2 plus 2? 0. So this whole part over here is going to be 0. 2 times 2 thirds, that's 4 thirds, minus 3?
It's a negative.
It's a negative number. That's really the only thing I care about, right? 4 thirds minus 9, it is really negative 5 thirds. We were going to get there. Times negative 2 is now a positive number. I've got a negative. Technically, I've got negative 10 thirds in the numerator. In the denominator, I've got negative 3 squared, which is 9. All I really care about is that that's negative. So my conclusion? Since d squared y dx squared at 1 comma 0 is negative, the conclusion?
The curve.
The curve is concave, which way?
Down.
Concave down. Look at the graph. Again, this is why they will never give you the graph. Look at the graph. Does that make sense? Is this graph concave down? At 1 comma 0. Is it a cup that doesn't hold water? I can look at the graph. Yes, absolutely. We're not going to worry about part D. I'm also not going to worry about the concavity at the other x-intercept because it's just the same process again with different numbers. Okay, so here's what I want to do. I want to give you guys some practice time. We've got 2, 4, 8, 10, 12, 15. Ugh, the odd numbers. All right, Christian, you're going to be the odd man out. You guys have 45 seconds to make 4 appointments. I want these appointments to be with people you are not currently sitting with. Partner up with somebody for 12 o'clock, for 3 o'clock, for 6 o'clock, for 9 o'clock. Christian, at each appointment, you're just going to join a group. But everybody else, you're partnering up. I need you to find 4 partners. When you're done, sit down with your 12 o'clock person and get started on the 12 o'clock problem. This would be the we're getting up and making appointments with folks.
2 o'clock.
Right, no one makes appointments with Christian. Christian makes his own appointments. You've got 30 seconds left. You need 4 appointments, then you need to sit down with your 12 o'clock person.
I'm taking that 3, sorry. Which one?
I got 12 and 6.
I have 12 and 6. 12. Show now.
I need 12. Does anyone not have 12?
Sitting down with your 12 o'clock person. I am not in the rotation. Sitting down with your 12 o'clock person in 10, 9, 8, 7,
I need
3, 6, 5, and 4, 3.
We're sitting down for 12?
And 2 and 1. Have a seat. You have 2 minutes on the 12 o'clock problem. Christian, go join a group. Okay. Show them what you can do with the 12 o'clock problem, please.
It's asking to find the D1, we just find the derivative. 2x. Ooh. Like we just kiss up D. No, do you erase it? Oh, you know, I use pen. Pens are where it's at, man.
This part I was confused.
Or should I know? I'm doing, huh? It's easy, I think. I want in favor, but I think that's still even. Almost got this.
dy over dx.
So I got plus 3 times 3 times 3 6 3y.
On the problem.
I think I got it. You done?
Well,
Oh, I see that's it. Okay, I am kind of messed up. I'm fully honest. So I got yeah, same. So we got 9y plus 2x times 3y over dx. How does this make it? I agree.
all right, folks, I want to interrupt all the good conversations that are happening. If all went well, your derivative is 3x squared plus 3 times the derivative of this xy guy. Haven't even taken a derivative of it yet. Plus 6y squared dy dx is equal to 0.
17.
To take the derivative of xy, that's where I'm going to need my product rule. Derivative of the first, leave the second alone. Plus the first times the derivative of y, that's my dy dx. I'm going to distribute that 3 through. Just like we did before, any term that has a dy dx stays together on one side. The ones that don't have the dy dx, those guys get moved to the other side. And then I can do a little factor and divide. So a great answer is this negative 3x squared minus 3y over 3x plus 6y squared. not one of the answer choices that they gave you, because you can factor out a 3 from the numerator and a 3 from the denominator and get them to cancel out. Did any of you guys get to A? A couple of folks made it to A. How many of you were on the path to A? Like another minute or two, we had it. Good. So we're gonna move on to the 3 o'clock. It's time to say goodbye to your 12 o'clock. It's now 3 o'clock. You've got 2 minutes. Show me what you can do with this next one.
Wait, 3 o'clock?
And go.
There. To getting it. That's getting it.
Let's find the derivative of x equals 2.
Think again. At x equals 2. Why is it just if
Where do you find the derivative? Then you look at.
Yeah.
Do you find the derivative differently? Because when I did that, I guess.
Was derivative y? You still have y. Why is that?
I'm gonna plug in 2.
I got -1 equals dy over here.
So all we do
It's okay for now.
All right, I'm not gonna give anybody the final answer yet, but if all goes well, your derivative should look like -2x minus y over x. How many guys have that as your derivative? Okay, we're in a good place. How are you gonna finish this off? Adriana, what are you gonna do to finish it off? Right, but I want to know what's the derivative at x equals 2. One of the challenges when it comes to implicit differentiation problems, you often have x and y in the derivative. I want you to find the derivative when x equals 2, but what you're missing is the y value. Where does that come from? You go back to the original problem to find the matching y value there. Finish it off.
Okay, so it's the derivative.
Alright, so we're missing Ranbir, Mariah, Nora, Jennifer O, Anthony,
Okay, so we plug 2. Then we plug 2 to this function.
and Eunice.
I think so. Yeah, you do. So you can get y. So then it's 10 minus 4 is 6, 2, 1. Y is just 3. And then you just plug it in back to the derivative. -2
Always on for y.
What is this? -4 minus 3. -7.
All right, friends, if all goes well, when you plug in x equals 2 into the original, you're going to get y is equal to 3. You take x equals 2, you take y equals 3, you plug both of them into your derivative expression, and you're going to get -7/2. How many guys honestly came up with -7/2?
After you get
Okay, we're making some progress. All right, 6 o'clock.
I don't have a 6 o'clock.
Ooh, this one's a whopper.
Just stay.
This one's a whopper.
I'm your 6 o'clock again.
2 minutes, show me what you can do.
Managed to finish anything. Let's try and finish this one. I thought I understood.
All for Y.
This thing is getting more nightmares.
I need this
That quiz is so funny. I got 200 and that's, it didn't even make my grade, but it did.
I got a 2x plus 2y times dy over dx. Is that what you got?
2x plus 2y of dy over dx?
Yeah. What do I get after we have 4?
Yeah.
Do I subtract 2x plus 2y? Do I divide? Do I subtract 2x plus 2y?
I feel like you take out a 2 in the dx, which gives you an x plus 1 equals 0. I think that's how you do it.
What did I do? dy dx? dy dx squared?
This is what, x plus y?
It's just low
Equals 0.
That's no.
Oh.
You're supposed to find the second derivative. Is it
But now I have to subtract.
is it camera?
I don't know. Does it have a light that tells you it's on?
It's creepy.
I just assume it's
All right, so. Okay, we can take the derivative first time, 2x plus 2y, dy dx is equal to 0. And everyone's good with that? When you solve for dy dx equals -x over y. I need to find another derivative, so I need a quotient rule. So low d high minus high d low, that's where that dy dx shows up, over y squared. I need to evaluate at 4, 3, so everywhere there's an x, I'm going to plug in 4. Everywhere there's a y, I'm going to plug in 3. 3 times -1 is -3. Minus a negative x makes it plus 4. And where's that -4/3 coming from?
dy over dx.
It's by going back to that original derivative at -4/3 and figuring it out, and then we just need to do some fraction work to get to -25 over 27. All right, I want to do one more with you all. If you guys flip over to closing questions. Somehow we only have 5 minutes left. In the perfect world where I control all the pieces, I would have you guys for a double block, and we would do math the whole time.
I would enjoy that a lot. Can we do that?
I know, but I do not control all the pieces, and 45 minutes ago, you guys were trying to find ways to crawl out of the window. No one wanted more time with me. All right, so fine, be that way. All right, closing problem number 1. 1 minute for a strategy conversation with whoever you're with right now. We're not even going to move. Just stay. I know you want to get out of this appointment. Okay?
Oh, what?
Have a strategy conversation with your person. What are you going to do to solve this problem? What feels right?
Relax. energy conversation. Oh, this is chain rule. Now it's more complicated. It's more complicated now because it's chain rule. There's a mom and a baby.
No, you're doing y. Y isn't a. It's not a variable. It's like.
So only if it has a number, you keep the number? So like if it was x plus 2y, would it be 2?
Yeah,
Oh. What is this?
Would the derivative be, so the x would turn into 1 for the baby, and then it would be plus 1 over dy over dx? Yeah. So it would be like 2?
And then you did what?
Yeah.
What's the negative sign? Or job?
Yeah, but what you consider the derivative? Because I have this.
Just remind me, and at that point I'll take you off the list.
1
Edgar.
times x
Hello, sir.
plus y times dy dx.
So this is 1 plus.
I thought it was the derivative of the stuff. That's not true.
Yeah, the derivative of the stuff.
X
This
turns
is
into 1.
x is turned into 1. 1 plus.
Oh, it's adding, not multiplying.
Yeah.
So it takes this off.
You were right, but you just.
Okay, so. Wait, so the y stays as a y, it doesn't turn into 1?
Y turns into y, dy dx.
Right.
Well, I leave. No, that's left alone.
Okay. So here's the good news. I got a chance to walk around and check in with a lot of groups. So many groups have a beautiful first derivative. Beautiful, beautiful derivative. I'm taking the derivative of cosine of stuff, right? So the derivative of cosine of stuff is negative sine of stuff
Yes.
times derivative of the stuff. Now, Amy, what's the derivative of x plus y going to be? 1.
1 plus dy over dx.
1 plus dy dx. Now here's the thing where things are getting messy out there. The chain rule says it's going to be negative sine of stuff times the derivative of the stuff. I really need to see parentheses around that whole expression because that all represents the derivative of the baby. And all that is going to be equal to 1. Great, I need to solve for dy dx. So what are some ways I could go about solving for dy dx? What's some legal algebra? Yeah, Giselle.
Divide negative signs of the stuff.
Is it legal to divide both sides by negative sine of x plus y? Yeah, it doesn't have to be pretty, it just has to get the job done. 1 plus dy dx equals 1 over negative sine of x plus y. Great, and now I just need to get dy dx by itself, so easy thing. Subtract 1. So dy dx is equal to 1 over negative sine of x plus y minus 1. And so what is that? Is that, hey, how many guys honestly had A? Okay, now here's the thing. The College Board wrote that question. They are being very kind to you. I'm the one that writes your unit quizzes and your tests and the trimester exam. I might not be this kind. I could hide this answer. Who sees it? How could I hide this from you? What would I do? Think tricky mathematician. Jose, what can I do here?
No, I mean, secant.
Let's be careful. You've had two different ideas, and if I put them together, they'd be the right idea. 1 divided by negative sine of stuff is negative. You guys are just trying to read my mind. 1 over sine, that's the reciprocal for cosecant. So if I really wanted to be tricky, I'd say it's negative cosecant of x plus y minus 1. That would be the derivative. That's another way I could write the derivative for the multiple choice. All right. Bell's going to ring in just a second. Told you. Okay, so 2 nights homework. You guys picked up another packet that says like release questions for implicit differentiation. I want you to